a time series can be replaced by x1, x2, xn, and xt are some numbers. And the basic purpose of time series is how to predict the next value xn plus 1 and based the previous observation x1, x2, xn. So, however, in this big data area, variance x. Okay, thank you. In this big data area, various complex data have received great attention since the data are sometimes incomplete and missing or concealed. And it is worth mentioning that we usually face the human regress the data whose value are not numerical but imprecise. That is, the observation are sometimes imprecise. Another one, among them, interview value data are the most used, such as the range of the weather temperature in a day and such as the range of carbon emissions in a week, the range of a factory society benefit in a month, and the range of the oil receipts in an oil field. Next. Okay, and so to deal with interview numbers, we have 6 mathematical systems. The first one is probability series. The second one is fuzzy set. The third is the interview analysis. The fourth is rough set series. The fifth is gray system. The last one is uncertain series. So we may ask which one is better than to handle interview numbers. Next, from uncertain series book from B7 and B10, we know fuzzy set series, interview analysis, rough set series, and gray systems are inconsistent. So, two mathematical tools remain. One is probability series and another is uncertain series. Next. In probability series, if we use a probability series to model interview numbers, we used a uniform random variable to model interview value date, but the addition of 2 uniform random variables is no longer a uniform random variable. And if we use the uncertain series to model interviewed date, we use the linear uncertain variable. The addition of two linear uncertain variable is still a linear uncertain variable. And on the other hand, the distribution function of interview value data obtained in most problems is not close enough to the real frequency. In this case, we should regard it as an uncertain distribution, and then we use the uncertain series. So we have six mathematical system to model interview data, but we just choose uncertain series to model interview value data. Next. So what is uncertain time series? And time series can be replaced by x1, x2, xn, and please attention, these xt are uncertain variable, not just numbers. And the first question is best x1, x2, xn they are uncertain variable and how to model it. Next. And now we have three models. The first one is uncertain autoregress model, and like equation 1. In this equation, while epsilon t is a distant term and p is called the order, and in this UAR model, space that the uncertain observed value depends on linear on its price value xt minus I and uncertain data balance terms epsilon t. And the second model is uncertain moving average model like equation 2. In this model, we call it the UMA model. Xt are not only infused by the epsilon t, and but also the data bands that then have taken before time t epsilon t minus j. And the last model is uncertain autoregress moving range model. And in this model, just mixed a UAR model and a UMA model. The first part is UAR model. The second part is UMA model, and just taking UAR model as an example, and I will show how to estimate the parameter. Next, and in UAR model, and how to give the A0, A1, and AP, and we based on least square estimation. If we have the solution of the minimum problem like equation 4, and then we give a series via uncertain distribution like equation 5. And if AI is greater than 0, we have this. This is 1 minus alpha if AR is less than 0, and this is alpha. So, and this is we give the least square estimation. So, next. Next, assume the distribution term epsilon t are IRD uncertain variable with expert value E and variance sigma 2. Then there is a problem how to estimate E and sigma 2. So we can define the residue. Next, we can define the T residue like this. So best the residue, then a suitable approach to estimating expected value E is like equation 6, and the y sigma 2 can be estimated by equation 7. Then we can predict the next value xn plus 1. So we call it next. So we have best the least squares. We got the hat A0 hat AI and epsilon expected value hat E and the variance sigma 2. So next problem, next question. Question 3 is how to predict the next value of the xn plus 1. And this is the basic purpose of uncertain time series. Next. So we can define the forecast uncertain variable. Hat xn plus 1 is defined as follows, just like this. And please attention, right equation, there is a epsilon n plus 1, and epsilon n plus 1 is uncertain variable with expected value hat e and variance hat sigma 2. And just we just defined a focused uncertain variable, and if we take this forecast uncertain variable x, so mu, the expected value mu is called the forecast value of xn plus 1. And so in real problem, we just give a pointer x meter it is not missing. So we give another concept. We call it the conference interview. Next. And giving alpha. Alpha is a giving index. And so alpha conference interval of xn plus 1 is defined as follows, and mu is the x value of xn plus 1, and while is b is the optimal solution of the following Maimonides problem. And please see this figure. Just we find mu such as alpha is greater than alpha, so we find b. So we call this is interview is alpha conference interview. And the next question is how to choose the p. P is the order of the UAR model. Next. So the forecast uncertain variable is depends on the order p. So next question is how to choose p. Next. And this is all the determinism problem. And we have a date. The data is x1, x2, xn, and we devote the date x into Xiangfeng set xe, x2, x1, x2, xt, and another is a testing set xt plus 1, xt plus 2, xn. So we just for a testing set xi, and minus the fitted value. Fitted value is like is this. We from got the fitted value from the fitted model. So we can define the arranging test error is like this, ATEP, and hat AJ as the estimate in the training set. So we just so we choose P such that ATE has a minimum value. And so after all, I just gave a simple model, UAR model, and how to estimate A1, A2, AP, and another how to estimate the data balance team expected value E and variance sigma 2. And The third one is give the focus on certain variable, and the last is give the how to choose the odd p. Next, and at last we give two numerical examples. The first example is a carbon dioxide, and this is data is collected from Canada is library from 1986 to 2011. Oh, 2017, and we have this data. Then we treat this data as a linear uncertain variable, and so we give the UAR model like this, right equation, and we give the forecast. We give the 15% confidence interval is like this, is radar. So this is the first example. The second example is Alibaba stock tick X, and this is just to give Alibaba stock tick is like this. The lowest and the highest price from this year, just one month, and we give the UR model is like this. We can hear the hot A1 is this, and A1 is 1.45, and the data balance X value is 0, and the variance is 3.8. So, and we give the 75% confidence interval is this. So, so this is my presentation. Okay, that's all. Thank you for your attention. And this is the reference.
So thank you, Dr. Xiangfeng Yang, for your nice presentations. I hope it's a new domain of research using uncertainty theory. So from participants, is there any questions? So you can ask the Professor Yang. So is there any questions? Please unmute yourself.
Okay, thank you, Chairman.
Is there any questions? So I have a questions. So in this time series analysis, so have you done any optimization, or it is just simple? Have you applied any simulation or optimization technique?
Yeah, absolutely. And the time series analysis is applied into like this as stock data and another and engineer problems like this carbon dioxide, carbon emission, and maybe we can apply the uncertain time series in some application more.
So have you used in any real life data? Practical data have you used?
Yeah, did.
Okay, thank you. Okay, thank you, Yang, for your nice presentations. I hope we will meet at 2 p.m. For next session by Dr. Leo. So thank you for this session. Okay, thank you very much. Okay, bye.
Okay, thank you. Bye.